Welcome to Rich Planet TV. I'm Richard D. Hall. How much of what you learned at school was true? In today's show, I am going to be discussing with Andrew Johnson a new theory about the development or the creation of planet Earth, and possibly all planets. Many observations about the Earth over decades have puzzled scientists who have concocted theories to attempt to explain what they observe, including theories such as plate tectonics, or the Earth's core is made of iron, or the primordial Earth was much hotter than today, etc., etc. Now, if the new theory we are going to talk about today is true, it means many textbooks will need to be rewritten. I'd like to welcome onto the show Andrew Johnson. Welcome back, Andrew.
Great to be back here, Richard, in the new wonderful studio. It's very impressive. Thanks for inviting me.
Okay, now, some people occasionally say, well, why do you keep having the same guests on, Richard? And I would answer that by saying, well, because the guests that I have on always talk about something new. Okay, you've done a lot of research into 9/11, the moon landings, Mars, and we've covered many issues. But this is a completely new area, at least for Rich Planet, and I think it's a fascinating theory. And we're going to mention the work of Peter Woodhead as well, who you've been collaborating with. Now, what impressed me about this theory, Andrew, is that it seems to explain many loose ends about our planet and possibly other planets. And I'm just going to list some of them that I've picked out when I've seen the interview that you did with Peter Woodhead, and also the papers that you've written with Peter Woodhead. Now, I think it could explain why larger planets are gaseous or become giant gas giants. It explains why the gravity of the Earth was much less when the dinosaurs were around, which a lot of people think. It explains that in the past, when the Earth had less gravity, when the dinosaurs were around, but the total mass of the Earth was still the same. It explains why some of the oceanic plates are relatively young. It explains why the Earth has oceans. It explains how the continents formed, and it also explains why the continents all seem to fit together. Now, but before we go into the actual theory that we're going to discuss today, just give us your understanding of what the accepted theory is on how the Earth came to be, where it is, like it is.
Right, well, I mean, you know, what I remember reading about many years ago, and I have to obviously point out that I'm not a geologist, I'm not a planetary scientist, as we've discussed before, Richard. You know, my background is in software, although, as you said, we've investigated these other things together in these various programs. So, you know, if I get some things wrong, then please forgive me. You know, I wish I knew everything about these topics, but I don't. But my understanding of, for example, how the Earth was formed is that there was a large accretion of mass from which the Sun and the planets either formed or were forming, and that was initially largely, you know, hot mass. And then at some point the Earth formed into a distinct body which was still very hot, and you know, you had periods of hot material, a globe of hot material essentially, and during a period around that time there was what they call bombardment, where you had these lots of debris flying around, you know, which was making up the other planets, the moons and so forth, and that was repeatedly coming by and crashing into the Earth. And a very kind of, hellish environment. And we ended up with what allegedly we have now, which is a fairly cool crust, outer crust. And then we have, you know, a breathable atmosphere. And then if you go further down, you know, if you were to drill down through the Earth, you'd go through the sort of layers of rock and so forth. And then as you went down, it'd get hotter and hotter and hotter. And then my understanding is that they say we have a molten core of iron. The core of the Earth is molten iron, because the story is that the iron is heavier than a lot of the other elements, and it's ended up basically at the core of the planet, and it's essentially liquid. And my understanding is that the reason, one of the reasons why they say that this is the correct model, is because that gives the Earth its magnetic field. So in other words, this molten core is in whole or in part responsible for producing the Earth's magnetic field.
Right. In this diagram that you referred to there, that we see in many, many textbooks, you think is possibly completely incorrect.
Potentially it is,
potentially.
yes. Yeah.
Now, let's briefly talk about Peter Woodhead, because really he contacted you with this theory, and his theory was built upon two other researchers.
Yes.
They are James Maxwell, is it?
Yes, correct.
And Neil Adams.
Essentially, yes.
Right. But Peter had actually, his theory is different in one very fundamental respect to their theories. We'll
go through that.
We'll explain their theories in a moment. But one thing that, because I've met Peter as well, Yorkshireman, and I think he's from Yorkshire.
I don't know. It's Lancashire.
Lancashire. I'm going to get wrong for that. It's on the Yorkshire border somewhere.
Yeah, it's close to Yorkshire.
Yeah.
Not quite near my old stomping grounds, actually. Yeah.
Right. Now, Peter said that he'd watched one of my shows where I interviewed Keith Hunter.
Yes.
Yeah. Now and you can watch those interviews. They're programs number 62 and 63 on Rich Planet. But just briefly, one of the things that Peter was interested in, that Keith Hunter was talking about, were imperial measures, the system of imperial measurements. So we've got the inch, the foot, the fathom, which is 6 feet, and then the mile. And what Keith Hunter suggests is that those measures go back eons. No one really knows at what point they were invented, but when they were devised to fit harmoniously in with the dimensions of the planet, i.e. the equator. And what Keith Hunter asserts in his book is that if you split the Earth up into 360 degrees around its circumference, and then each degree into 60 minutes, you get a minute of an arc around the circumference. And each of those minutes used to be perfectly 6,000 feet, or 1,000 fathoms. So the entire circumference of the Earth would have been 21,600,000 fathoms, right? And everything fits into it. Now he gives quite a good reason why he thinks that, and it's to do with the 360-day year, because Keith Hunter comes up with a ratio between the 365.25, whatever it is, days that we have in our current year, and he divides 360 over that to come up with this 1.15 ratio, and he multiplies that by the current circumference of the Earth. And he comes up with a new circumference of the Earth where, strangely, the circumference is exactly, or 1 minute of arc fits exactly into 6,000 feet. So what Keith Hunter would say is that at some point the Earth's circumference was 1.15 times less in distance. It was smaller physically, and that's possibly around the time when the imperial measure system was introduced, which could have been millions of years ago, for all we know.
Possibly.
So that's where Keith Hunter's coming from on this, and Peter Woodhead was scratching his head over that, and he'd seen other researchers such as James Maxwell and Neil Adams. Now, can you start, Andrew, by telling us what James Maxwell and Neil Adams are famous for in their research first, and then we'll point out what Peter Woodhead's modification is on that.
Yeah, so Neil Adams and James Maxwell, they have looked at this idea totally independent of Keith Hunter, that the Earth was a different size in historical times, and it was actually smaller. And they've come at it in slightly different ways, and I know from correspondence, certainly with both of them, that Dr. Maxwell, he is a geologist, PhD geologist, so he's thoroughly scientific. And Neil Adams is an artist. He's actually a comic artist, and still, to my knowledge, he does a lot of work in that area. And I actually did an interview with Neil Adams quite recently, actually. as a result of developing this theory with Peter, Neil Adams, we'd agreed, I got in touch with him and he wanted to do an interview to basically try and explain why we must be wrong. But they came at it separately. Dr. Maxlow had done a lot of geological research. In fact, he did his PhD on this idea that the Earth was historically a different size, different circumference from what it is now. And he'd done a lot of models on this, and he'd looked at various geological records. And Neil Adams had actually made some CGI animations which illustrate this very well. And these have been on YouTube for I think almost 10 years now.
We can put a link up on the screen to these
Right.
two researchers' research. Yeah,
absolutely.
Right.
And you look at these animations that Neil Adams has produced, and they've got a lot of hits. I think quite a few people have become aware of them in the last 8, 9, 10 years, and they are very well made. He produced at the time in his own studio. He had a digital animation studio which he'd set up himself for his own productions, and then he'd utilised that to produce some of these animations. And this visualises what we're going to come on to very powerfully, I would say. And then what I should say is there is a history to this which ties in to a large extent with the standard model that we're going to also talk about, which is plate tectonics, which you'd mentioned. And I studied that. Well, I was shown that in geography at school. I did about plate tectonics. We'll explain what that is as well.
Right. All right. Well, we'll go for our first break now, and we're going to expand more on this shortly. Welcome back. I'm talking to Andrew Johnson about an alternative theory of how the Earth was formed. Now then, let's just go back and look at what the science books say. Tell us about continental drift and how that was considered in the early 20th century.
And this, I think, goes back even to the 19th century. Somebody had observed, that the continent of South America seemed to kind of like be a bit of a jigsaw puzzle that fits with, the African continent. And so then somebody came up with this idea, well, maybe these continents have actually been moving over time, and people said, no, that's ridiculous, because the Earth has always been here, God created it, it's always been like this, it's never changed, so that can't be right. And then there was a chap called, I think his name was Alfred Wegener, in about it was the early 1900s, I think it was 1912 or 1918. He proposed this idea of what was called continental displacement, and which then was renamed because people didn't like this idea of these land masses sort of moving around. Now, that doesn't happen. And they called it continental drift as a way of kind of ridiculing it or partly ridiculing it, because displacement is a more scientific word and drift is kind of like, oh, you're just drifting around, don't know what you're talking about, And so there's a bit of language issues used there, and we're all very familiar with how that works, aren't we? But then it was actually, they started to measure this, that the continents were actually moving apart, and you've heard the statistic that, England and America are getting 1 centimetre, or whatever it is, further apart every year. And that was then measured, I think, in the sort of mid 20th century, more or less. And then they thought, oh yeah, the continents really are moving apart, so that's when it's called continental drift. And then they came up with this idea that what's actually happening is we've got this kind of semi-solid inner Earth or surface layers, and then floating around on the top of that we've got these more solid layers, and that we've got these plates. In other words, the Earth's crust is made up of these plates, and these are floating around, sort of on a kind of the liquid mantle, which is where all the lava and stuff comes from. That's underneath. It comes through the mantle. And that's sort of slightly lower down. And so all these continents are moving around, and that's where we get this idea both of continental drift, as it's called, and plate tectonics. And then I suppose the next development of that was where they looked at the mid-Atlantic Ocean, and they found that on the seabed of the mid-Atlantic Ocean, they'd found these ridges, these hardened ridges of lava that had solidified over hundreds of thousands of years, and basically there was this spreading, the ocean floor spreading. It was spreading from this central fault line, which was volcanically active, and they've sent submarines down there and filmed all the volcanic vents, and there's various things going on down there. And then they were also able at that time to measure the age of this ocean floor spreading and measure how quickly it was happening, because what they observed in this rock, there were ferrous materials which had become magnetized due to the Earth's magnetic field, and they noticed that this magnetic field had flipped. I forget the exact figure, but every so many tens of thousands of years, or hundreds of thousands of years, and so they're able to age how old these parts of the seabed were. So this is one of the key studies that was started in the 1950s, and they did various surveys around the world and looked at the ocean floor, and they measured the age based on these magnetic field reversals. And the very peculiar thing that came out was the oldest ocean floor that they could find was dated to around about 180 million years. So even if you go right to the coast of America, the east coast of America, or the western coastal parts of Europe and Africa, the oldest ocean floor is only 180 million years, whereas the age of the Earth is estimated to be about 4 billion years old, according to all the geology textbooks. So that presents you with a bit of a problem, because the ocean floor is much newer, by hundreds of millions of years, than the rest of the geology on the planet. So then they sort of said, well, if these ocean floor is spreading, and we've got the continents moving apart, then what must be happening somewhere else that we can't see is that the continental plates must be going under another of the ocean plates elsewhere on the planet, because then the ocean floor stays the same size and the Earth stays the same size, and what we're getting is subduction. And so the continental plate is being forced under either another continental plate or under an oceanic plate.
So this is a generally accepted geological phenomenon called subduction.
Subduction, correct.
Right.
That's one of the key things.
Which really is a theory.
It is essentially a theory. Now, they'll claim that there's certain evidence for this in the Far East, and they say that there's subduction going on in some of the areas there, and they can prove that this is where the continental plate is being destroyed, because it's been subducted under another plate,
right,
and it's going back down into the lower areas of the Earth.
So let me interject there. So they're trying to explain the phenomenon without having to say that the Earth is expanding.
Yeah, essentially.
Right. Now let's just look at a few other areas that have geologists, or I don't know what you'd call them, paleontologists, scratching their heads, and that is finding things that should belong at the bottom of the ocean on the top of mountains, such as fossils, and also the physiology of dinosaurs.
Yes.
Just
yes.
tell us about that.
I mean, everyone knows, everyone's taught at school, probably in primary school, that dinosaurs were huge creatures. There seems to be good evidence for this, because we have skeletons, and they've reassembled these, and they're in the Natural History Museum, and they're huge. The Brontosaurus, you think, wow, these things are amazing, and you're fascinated as a child by these things. But then, when you start to look at this, you think, well, hang on, if this was at least a bit like some of the creatures we have now, then how did it live? Because, for example, if you calculate the required pressure to pump the blood from the animal's heart up to its head, the heart would have need to have been so big, it wouldn't have had anything room for anything else in its body almost, because of the pressure that you'd need. But even I think more simple to calculate is things like weight ratios. If for example you calculate the surface area of the foot on the ground, and then you calculate the weight that foot has to support of the animal, as you get bigger and bigger, you find that the dinosaurs' bones and feet and so forth could not have supported the animal's weight based on the force of gravity that we have now. So if you do the calculations that you say you would do for an elephant or a giraffe or something, the dinosaur is no longer viable. The problem becomes even more severe for the dinosaurs which flew. because the problems that you have there is that, you know, power to weight ratios, wing surface areas and that sort of thing, they're much more extreme than for land animals, where you're dealing with, you know, mechanics and mechanical areas and that sort of thing.
So that whole observation suggests that the force of gravity was possibly less, say, 100 million and more years ago.
Correct.
Right.
Correct.
Now, what about oceans then, and things that are found in areas perhaps where they shouldn't be? Tell us about that.
Well, of course, that's another interesting area. I mean, I remember being set this question in geography, or this question came up in geography class. Where did the oceans come from? You know, you read the textbooks about the dinosaurs, for example, and they all say, in the time of the dinosaurs, there were no deep oceans, only shallow seas. So one of the big geological mysteries is where the deep oceans came from. How did we get those? And that's not really explained very well. You'll hear, for example, talk of, well, there's two problems. One is how come the oceans are so deep, and the second problem is where did all that water come from? And, you know, people will say, for example, that comets, the water came on comets, these balls of ice which were in the primordial solar system, and we had hundreds of thousands of these comets crashing into the Earth, and they brought all the water. But that doesn't really, if you forgive the pun, hold water when you start to look at all the problems with that theory and the volumes and so forth.
So some people have put forward that if the Earth's gravity was less in the days of the dinosaur, going by Isaac Newton's gravitational law of gravitation, F equals J/m over r squared, they say that, well, the Earth must have been less massive.
Correct.
To have a less gravitational pull on
Correct.
the dinosaurs. So therefore, they come up with the theory that the Earth has not only been expanding over millions of years, but actually gaining mass. More stuff has been added to it somehow by some magical process. And am I right in thinking that both James Maxwell and Neil Adams both support that view?
Correct. That's one of the key issues that when we get onto Peter Woodhead's ideas in more detail in a few minutes, that's one of the sort of nubs of the problem. That James Maxwell, who has done a lot of geological research, which to me at least proves that the Earth must have been a different size in the past. It must have been smaller. He, as you say, he thinks the mass was also lower and the mass has increased. So we've got this extra mass which has made the force of gravity now much stronger than it was in the time of the dinosaurs.
Right, and that's where Peter Woodhead comes in.
Yes.
Because he says, no, the Earth's mass has been constant,
correct,
but it has been expanding. And we'll explain how that works after this break. Welcome back. I'm talking to Andrew Johnson about the creation of the Earth and the new theory which suggests that the Earth has expanded from a much smaller sphere but has not gained any mass. Now, this is Peter Woodhead's idea, and
yes,
you met Peter Woodhead, what, about a year ago, something like that? Or
yeah, it's a bit longer than that, but yeah,
so
essentially.
just tell us what conversations you've had with him in developing his theory.
Well, you know, this was the thing. I'd agreed with Neil Adams and Peter and James Maxwell that the Earth must have been a different size in the past. It must have increased in circumference, in radius, and so forth. And Peter wrote to me. I think he'd seen me on Rich Planet actually, and we talked about Keith Hunter, and Peter had watched that program, and that set him thinking. And then he says, "Oh, Andrew, I've got the explanation for how the Earth has expanded." And I thought, "Oh, that sounds interesting." And eventually I was able to meet up with Peter, and he sent me some of the calculations he'd been doing, because he has made some calculations, which we may talk a little bit about, although they're not essential to describing this theory. And it is a theory, but I think there is sufficient evidence to back it up that I think it is probably correct. He'd seen some research about looking out into the distant sort of distant parts of our galaxy, or the stars in our galaxy, and astronomers in Atacama, they call them the Atacama astronomers, a team in Atacama, they'd observed what they called a snow line around a star. So they had a star in the centre of this solar system, and around this they'd observed a sort of ring of frozen water. And I think this idea was mentioned in this article about this snow line around this star, that the planets were forming there. So Peter thought, well, hang on a minute then. Maybe that means that when the Earth formed, it wasn't all this hot bubbling, mass, from that was spat out of the sun or whatever, or spun off from the sun, or accreted from various rocks that were floating around, crashing into each other. Actually, what was there was primarily ice, and it was formed from a lot of ice. And then around the ice, you had the rocky layers, the heavier elements, the metallic elements, and so forth. Obviously, everything we've got now. And so that formed into a globe, and it was a smaller globe than it is now. And but essentially, it wasn't this primordial fireball. It wasn't like that. It was much cooler than that, and maybe not. A lot of it wasn't that much hotter than room temperature. And what Peter has argued was that actually the core of this ball of the Earth was actually ice, and it actually was, physically a solid block of ice. And so you had the ice in the core of the Earth. So we started off with an ice core, and then around that you had this rock and these heavier elements, including radioactive elements, for example. Everyone knows that radioactive elements are a source of heat. And so you get in that radioactive heating, and Peter's cited some articles which show that a large percentage of the heat in the Earth's crust comes from radioactive isotopes. So there was that. So what you've got is radioactive isotopes around the ice core, gradually heating up the core. And there's a limited place this heat can go. It goes into the core. And what James Maxwell observed is that for up until about 300 million years ago, there was no Earth expansion. That from the geology that he'd done and looked at, James Maxwell said there was no Earth expansion until about 300 million years ago. And then all of a sudden, boom, it starts expanding. And it expands exponentially as well. So what Peter argues in his article is that the ice core, over billions of years, in fact, 3,700,000,000 years approximately, the ice core had gradually melted, turned to water, and then the heating continued, and then 300 million years ago, the water in the core started to boil. So that boiling water then started to create pressure, and then that began to make the outer layers expand, and that's why the expansion only started about 300 million years ago, and it's still going on today.
Now, this is all spinning as well.
Yes.
And you cite a NASA experiment which has clearly been done in zero gravity of a sphere of water, a solid chunk of water in a sphere, as it would be.
We'll show this video,
in zero gravity, which is spinning.
Correct.
Which is water in zero gravity spinning.
Correct.
Which is similar to what he's saying that the Earth started as.
Yes.
But they inject some solid material into that as it's spinning.
Yes.
And just explain what's going on, Andrew, in this clip.
Well, if you look at that clip, it's I think they explain it in the clip itself. You'll see that the heavy materials actually go to the outside, and if you take this droplet of water, maybe it's just like a teaspoonful of water, and you can add to it because you're in zero gravity. You can make this sort of globule of water bigger, and it does form a perfect sphere. You inject air bubbles into it, and the air bubbles don't come out and fly out. They actually go to the centre. So the lighter materials end up in the centre of this droplet of water. Mm-hmm. So we're saying that what actually happened with the Earth was when the water started to boil and become water vapour, although we got pressure, some of those gas bubbles actually ended up in the centre of the Earth, because what we argue is that the way that gravity works inside the Earth is different to what the textbooks say. Right.
Now let's come on to that then. So the two researchers that we mentioned earlier, James Maxwell and Neil Adams, are saying, well, if the Earth is growing in its circumference, there must be some more material being put in.
Correct.
Whereas Peter's saying, no.
Correct.
It's changing its topology, if you like, i.e. there's something in the centre which is pushing the mass out like this.